Okay, so we've moved from doing a pencil experiment where we've seen where when you've dropped your pencil, the marks are very, very close to the target that you were aiming for. Then we did a simulation with throwing darts, and we found that the dart is more towards the center of the board. I mean, what was that called? The bullseye, right? And now we're going to officially move into this model of the atom. So notice that in the middle here, we've got our protons and neutrons. So this would represent our nucleus. We have a couple of electrons that are floating around the outside. And we want to figure out what is the pattern of where electrons are most likely going to be located. I can change the amount of time between finding where the electrons are located. So we're going to start relatively long, which means we're going to be moving relatively slow. We click start. We start to see this pattern emerge. If I stop right there, could I say where electrons are most likely going to be located? Maybe not. So let's go ahead and click start again. Now we're starting to see a similar pattern to what we saw in the pencil drop and the dart target. What is that called? Dart bullseye, right? Now let's speed this up a little bit. Let's take less time between finding where those electrons are at. And let's let it rock and roll. So there's two things that are happening that we really need to think about. The first one is, why are so many electrons so close to the nucleus? Why does that happen, right? Do you notice how it's getting like even darker red the more we let this run? So that's one thing. The second thing, though, is why do electrons space out, though? Like there's some that are way kind of out here. Why does that happen? What's going on with forces of attraction and forces of repulsion?